Okay, we're on FRQ 2017 FRQ number 4, and this is about a boiling potato. So at time t equals 0, a boiled potato is taken from a pot on the stove and left to cool in the kitchen. The internal temperature of potato is 91 degrees Celsius. All right, so far we got two important pieces of information. At t equals 0, it is 91 degrees, right? The internal temperature of potato is greater than 27 degrees for all times t greater than 0. So at any time you're looking at, because it's positive time, your internal temperature is going to be greater than 27 degrees Celsius, right? The internal temperature of a potato at a time t minutes can be modeled by a function h that satisfies the differential equation d of h equals negative 1/4 h minus 27, where h of t is measured in degrees Celsius and h of 0 equals 91. This is already what we said in the first highlight there, right? So run the equation for the line tangent to the graph of f of h at t equals 0. Use this equation to approximate the internal temperature of a potato at t equals 3. So again, the word tangent, right, tells us that we need to find the slope, but we don't have to. We already have the slope here. So the slope is dh dt is this equation here. So we're going to use that to find the slope, and we do have a point. The point is 0, 91. So these are our x and y values, and then we can use that to write my linearization, my tangent line equation. All right, so let's find slope first. So slope equals dh dt, which is negative 1/4 times what is h? H is your temperature. At this point, temperature is 91. So 91 minus 27. Okay, so let's figure that out. That's negative 1/4. 91 minus 27, that is 64. And that will give you negative 16. All right, so then your tangent line is y equals negative 16 mx plus b, right? Y equals mx plus, and this is an intercept, y-intercept, so it's just plus 91. Okay, so now we're going to use that to approximate t equals 3. So, well, let's not put y. I think y is a little confusing that way. We can put L of x, right? That's a linearization. So we're going to approximate 3. So negative 16 times 3 plus 91. That's negative 48 plus 91. That is 43, right? So it's about 43 degrees Celsius for my estimation. Okay, so now it says use the second derivative to determine whether your answer in part A is an under or an overestimate of the internal temperature of the potato at t equals 3. So let's take the second derivative. So dh dt, so that's your h prime, is equal to negative 1/4 h minus 27. So h double prime equals your coefficient negative 1/4 times h prime, because that's the derivative of h. Minus 27 is a constant, it's gone. But then now you got to plug in the h prime back in. So this is really h double prime equals negative 1/4 times h prime, negative 1/4 h minus 27. So this is really 1 over 16 h minus 27. Okay, so think about it. At t is greater than 0, at any time after this, your temperature is always greater than 27. So remember, your temperature is always greater than 27. So no matter what I plug in there, it's always going to be positive, right? So any number bigger than 27 minus 27 is going to be a positive number. Multiplied by positive 1/16, this is going to be positive. So h double prime is always positive, therefore concave up. What does it mean, concave up? When it concaves up, it looks like this. Your tangent line is always going to be right underneath. So your tangent line is going to be an underestimate, right? So that's why the part B. So tangent is below. So part A is underestimate. All right. Of course, when you're writing this out, please don't try to squish your answer here. You will have plenty of space to do it. I don't, because I'm trying to fit it all on this one page. Okay. All right. Lastly, for t is greater than 0, greater than less than 10, an alternate model of the internal temperature of a potato at t minutes is this function g that satisfies the differential equation d of g over dt equals negative g minus 27 to 2/3, where g of t is measured in degrees Celsius and g of 0 is also 91. So your initial conditions right here. Okay, find an expression for g of t based on this model. What is the internal temperature of the potato at t equals 3? So first thing you want to do is find the equation, find the expression for g of t, meaning you're going to solve for the equation, right? So d of g over dt equals negative G minus 27 to 2/3. All right, so you're gonna move some things around, right? You want to make sure your separation of variables, move your variable to one side and move your other variables to the other side. So in this case, because G minus 27 is kind of one term on its own, I'm just going to move the whole thing over. So D of G over negative G minus 27 to 2/3 equals dt. So multiply dt over. All right, now you can take the integral. So this is going to be, before I start taking integral, I am going to go ahead and say, just rewrite it, negative G minus 27 to the negative 2/3 dg. I think that's a lot easier to take the integral of. Okay, so negative G minus 27, negative 2/3, add 1 makes it 1/3. Don't forget to multiply reciprocal times 3. There is no coefficient from the G itself, so that's it, equals T plus C. All right, so now that I have this plus C, I can now plug in my initial condition. Remember, T equals 0, G equals 91. So I have negative 3, 91 minus 27 to the 1/3 equals 0 plus C. All right, so negative 3, 91 minus 27, that is 64. 64 to the 1/3 equals C. 64 is really 4 times 4 times 4. So to the 1/3 is times 4. So C equals negative 12. All right. So now I can go ahead and put it back in my equation. So negative 3 G minus 27 to the 1/3 equals negative 12. Oh, sorry. T minus 12. So that's my equation. Now we're going to have to, based on this model, find the internal temperature at T equals 3. So at T equals 3, plug it in. All right, you can clean this up a little bit, but it's totally fine. So negative 3 times G minus 27 to the 1/3 equals 3 minus 12, right? So negative 3 G minus 27 to the 1/3 equals negative 9. Divide by negative 3 on both sides. G minus 27 to the 1/3 equals 3. Now cube both sides. So G minus 27 equals 27, right? So then you will get G equals 54. So the internal temperature at T equals 3 is 54 degrees Celsius. Okay, that's it, guys.